Okay, so just kind of a note here. Come in.
Hello. Say NIV agent here. Let's get this.
Are you getting?
Yes, I've been requested by people.
Oh, I was like, are you actually buying that much stuff?
Nope. Central William. Mason.
Thank you. Thank you. You actually know what to do with an empty box.
Usually I break them down.
No, but I mean, I don't care about that part. People leave empty boxes up here, and it drives me insane. If you take the last one, throw the box away.
Are the muffins 50 cents?
They're $1.
So that's $1 right here. What are you guys doing in class today?
Calculus.
Calculus. The easiest form of pay. Huh? The easiest form of pay. Actually, no. Just kidding. No. Last paper. Oh, wait a minute. This is hard. Okay. People get a lot of stuff. This. No, this is $1.50. Okay. Sorry. Can I be a door real fast? So I put $1 in there. Wait, no, I put $5 in there. Yeah, I'm thinking.
$4. What you have in your hand is all that's $4.
$4. All this.
Yes.
$4. Okay. So $2. Just $2. Okay, I'm tired right now. Okay. It's a long day.
Secret Service can't fall down on the job, man.
Yeah. That's why I'm an
I know, that's why I was like, I can't. Like, to whoever watches this video in the future, I know you're confused, but it was a comical time. Okay, anyway, so sometimes we write df is f prime of x dx, which is literally just representing a differential. So, just another way to write it. Okay, so these problems say, write a differential formula that estimates the given change in volume or surface area, then use the formula to estimate the change when the independent variable changes from 10 centimeters to 10.05 centimeters. So, 32 is a surface area problem. The change in the surface area, S is equal to 4 pi r squared of a sphere when the radius changes from A to A plus dr. Alright, and we were told in the instructions that A is 10. So first I want to take the derivative of surface area. So what would the derivative with respect to radius be? Like take the derivative of r.
8 pi r.
Well, dr, but yes.
Oh. You said A or 10 stands for A?
Yeah, that was from the instructions. It said that we're looking when the variable changes from 10 to 10.05. So then dr is 10.05 minus 10. And again, that was just from the instructions. It told us that that's what we were changing from.
It's dr because it's respect to r, right?
Yeah, because it would have been ds dr would have officially been how we would have written that. Because it was the derivative of surface area with respect to radius.
Yes.
So then now we plug stuff in. So we do ds is equal to 8 pi, r is 10. Okay, so I said like a is 10, r is 10. It's all the same thing. It's just plugging it in, basically. So 10, and then dr is 0.05. And you can leave it in terms of pi, so like your answer can be something pi.
So 4 pi.
So 4 pi centimeters squared. So that's the change in surface area, is what this represents.
And r equals a.
Yeah. Okay, so now, next one. It's another surface area problem, slightly different instructions. Okay, but it, basically for the surface area, there's also a volume problem that goes with this one. So we did the even one, the odd one is the same principle. It's just volume instead of surface area. So the next problem is another surface area problem. It says the change in the lateral surface area, or well, I guess these are the same instructions. These are the same instructions. Okay, never mind. Scratch that. It's on a different page and it looks confusing. Okay, the change in the lateral surface area S equals 2 pi r 2 pi r h of a right circular cylinder when the height changes from A to A plus dh. And the radius does not change. Okay, so that's important because what that information right there tells you, radius doesn't change, so it's a constant. Okay, so we're not taking the derivative of r. It says that height is changing from A to A plus dh. Okay, so height is equal to A or A plus dh, okay, as it changes. So we're taking the derivative of surface area with respect to height. Okay, so imagine that r is a number when we take the derivative, basically. So ds is equal to just taking the derivative of h, which is just 1, so it's just 2 pi r dh. So then again, like we found dr, okay, dh would be equal to 10.05 minus 10, again, just from the instructions. So it's 0.05. So then I can plug stuff in. So ds is equal to 2 pi times, they didn't give us a value for r, they're just saying it doesn't change. So r, and then times 0.05. And so again, you can leave your answer in terms of pi. So 2 times 0.05 is what? 0.1 centimeters squared. So again, that means change in surface area. All right, now there is in fact a new set of instructions. I can read. It says, use differentials to estimate the maximum error in measurement resulting from the tolerance of error in the independent variable. Express answers to the nearest tenth, since that is the precision used to express the tolerance. Okay, basically all the stuff that they tell you is plus or minus, like 0.1, 0.3, 0.5, something like that. So that's why we're going to 1 decimal place for these ones. So 38 says the volume of a sphere with radius 8 plus or minus 0.3 inches. Okay, so this requires you to know a little bit of information. What is the volume of a sphere? That would be area. Well, that's part of area, but a little bit more for volume.
Area is sort of like pi times radius squared.
Mm-hmm.
Okay.
So volume would imply you need the radius how many times?
3 times.
Okay, so that's part of it. So pi r cubed.
And multiply the height.
There's a number that's in front. There's no height in a sphere.
Half.
4/3. 4/3 pi r cubed. It's an important formula to know when it comes down to the AP test. So I would stick that in here. Put it in your noggin. All right, so this value here, this 8, is your R value. This 0.3 is your DR. So we're going to take the derivative. So the derivative of volume of that volume equation would be what? Don't forget the DR on the end. So now we just plug in these numbers. So dV is equal to 4 pi times 8 squared times 0.3. And this time they do want you to multiply the pi through because it wants our answers to the nearest tenth.
What?
Did you multiply that by pi?
No.
That's why.
76.8.
I think. Yeah, you'd be right if you just multiply that by pi.
I can't multiply that by 5. It's like 3 more digits.
Did you get it, Sarah?
Yeah.
What is it?
41.
And 1 decimal place?
241.27.
Okay. Inches cubed, because it says it wants us to go to the nearest tenth, because that's the precision used for tolerance in this. Just- Come on, there we go. All right, so one more problem. Expanding a circle. So the radius of a circle is increased from 2 to 2.02 meters. And this is a two-part problem. So part A says to estimate the resulting change in area. So now, what is area of a circle? Pi r squared. Okay, my dr value is 2.02 minus 2, which is just going to be 0.02. Okay, so that's going to be the dr value I'm going to use. So take the derivative of area with respect to radius, and you get what?
2 pi
And?
dr.
Okay, now we're going to plug it in. So 2 pi r, so we're using the initial r value, okay, when we're plugging it in. So that's times 2 times dr is 0.02. So the change in area is what? I don't care if you multiply the pi through or if you don't, it doesn't matter to me.
pi.
0.08 pi, and the book tells me that that is equal to 0.2513, just in case you're so inclined to care. Alright, so then part B is a little bit interesting. It's different. It says to estimate the as a percentage of the circle's original area. What'd you say?
Can you go back up just a little?
I still don't know what you said.
Can you go back up?
Oh.
Just a little?
I was like, huh? I thought you were trying to tell me what I was supposed to do for this problem, and that's why I was like, what are you talking about? It's been a long day.
I know.
And second period, I thought it was like supposed to be lunchtime.
I thought second period took forever.
I agree.
I have no idea why.
I didn't even start class till the bell rang, and I thought it took forever.
Yeah, I don't even know. I just was like, wow.
We might have gone past like 10:15.
We got there at like 10:10. Changing suits. Look at this.
Did your sisters fight over who was going to get to go with you?
No, they actually didn't really even know about it. I just kind of was like, "Hey, Violet, you're coming with me." She looked at me. She's like, "Huh? Okay." And then, of course, Gigi goes, "Why can't I go?" And I was like, "Violet's older."
That's not fair.
That's why I was just wondering. I was like, how did you decide who was going to go with you?
Yeah, well, because Violet did it last year, and I thought it'd be fun. She did this year, so I was like, "I'll let her do it." See?
All right, so estimate is a percent of the circle's original area. So what we're going to do for this one is we do dA over A times 100. Okay, because that's going to give us the percentage. So the derivative of A was 0.08 pi divided by A is pi r squared, so pi times 4. And then all of that times 100. So this one's actually pretty easy. The 100 makes this decimal point move over 2 places. So that becomes 8, and that's gone. The pi's cancel, so I'm literally just left with 8 over 4, which is equal to 2. So it's 2% of the circle's original area. Hold on a second. Let me see what okay, I saw 23. Okay. So then adding on to what I gave you yesterday to look at 31, 35, and 39 would be similar to what we just looked at.